I've not bought any SpaceX stock, but people say it could be a $30 trillion company.
So the question is, how do you assemble that million or 100,000 token window to be the most effective for the task you're trying to do?
And you could see in a matter of 3, 4, 5 years, it was pretty evident that my ISAM is dead because it didn't have protection and safety.
The biggest thing that the LLMs are missing is the deeper context about the customer, the enterprise that they are serving.
We live in this really exciting era of learning. I would just call it learning.
Yeah. If my goal was customer support, then I would be organizing things around like product features and areas where bugs get organized and different kinds of problems.
Obviously, SpaceX has gone public, right? And XAI is the new AI company. I mean, it's very clever how they're going to be a data center company. And my conjecture is that it will really make the Neoclouds.
We can make fun of the idea of token maxing. But the intent behind token maxing was to push people's imagination. All right.
Well, good morning, Amit.
Good morning.
It's been a while, right?
Yeah, it's already summer.
And it's been maybe 3 months, because the last episode that we did was with Abhishek Bhaumik on quantum.
Yeah.
And looks like AI has taken a quantum jump in the last 4 months alone. So do you want to say a few words about how things have been and where were you? And let's talk a little bit about the quantum jump in the last 4 months.
Yes, so much has happened. I think the last episode about AI we had with Alex, since then, obviously Cloud Code and Cloud Cowork has come out. People have been token maxing, and the pendulum has started to swing in the other direction, where at least some organizations are clamping down on token maxing, and people are talking about impact maxing and all the debate that rages around it. I heard from a friend that apparently one intern at Snowflake spent $1 million in tokens as they were preparing
they
for
needed a job, actually. The best way to convince somebody to give them a job is to max out all the tokens.
Talk about hiring cheap labor, you know. Like I'll get an intern for $5,000 a month and get some work done.
Yeah,
and next thing you know, you have $1 million bill. Well, hopefully it was worth it.
Yeah, I mean, Snowflake has to compete hard against Databricks, so they probably need to figure that out. But yeah, I mean, going back to a quarter ago, you talked about Cloud Code, Cloud Cowork. The emphasis of kind of going away from prescriptive frameworks like LangGraph, where people were, hand stitching workflows together, to completely autonomous React loops, which is reason and act, and the idea of autonomous agents definitely has been a big one. We've started to use the word harness a lot, I guess, in the last 3 months. Sandbox and even session. The idea of a session has become really important. But any conspicuous sort of companies that you feel have become less meaningful now than before because of the advances with not just LLMs but also with the idea of harness and agent SDKs and things like that?
So you mentioned LangGraph, right? I think where LangGraph started, it was never going to find ground there anyways. It just got them the market recognition, but now all the money they make is essentially in observability, and that'll
on someone else's harness.
And I think that's where probably that company will stay relevant.
I mean, the whole idea of using compute differently is obviously a big change. I mean, we'll talk about CPUs and GPUs at some point as well, because it matters. But what's your take on the word compute itself? Like, how has it evolved in the last 3 to 6 months? As it relates to the hardness.
So essentially what has happened is that the reliability of the code being produced from the frontier models, in particular like Cloud Opus or for a little while Fable.
Are you an American? Don't talk to me like that.
Has been so good that now you just kind of, you give your intent, the models generate code, and you can run that code without actually thinking that this code is going to do something random. This obviously it's not 100%, and there are ways to recover from those errors, but it's reliable enough that you want to try it in the first shot without examining the code. And so what that means is that you're not limited to the tools that you had given to your agent. It can create its own tool on the fly, and that means those tools are obviously using CPU and compute a lot. So
I mean, but even this advent of Grep and awk and sed playing a big role in the harnesses overall loop. Say more on that. Like, what happened in the last 3-4 months? I mean, obviously within Anthropic for a year, that made it extremely useful for the developer and now for the non-developer.
So particularly Grep, sed, awk, right? It's a question of, obviously the context window keeps growing, but it's never going to be enough. So I spend a lot of time analyzing call transcripts, hundreds of calls, right? So not all of that is going to fit in the 1 million token window. And it's also not wise to throw everything in the token window, right? Because then that distracts the model in other directions. So the question is, how do you assemble that 1 million or 100,000 token window to be the most effective for the task you're trying to do? And it used to be that most of the knowledge was kind of relatively static, and you throw it into a searchable index, vector DB or something, and you pull from there. But now the stuff is dynamic. One day I'm analyzing calls from like one team, another day I'm analyzing from another team, another day I'm analyzing calls from a particular vertical, and these things are constantly evolving. I mean, you could still put those things into a search index, but what it seems through trial and error, Anthropic and others have found, is that actually it's much more effective to just run some on-the-fly searches using Grep, sed, awk, and find the relevant pieces and assemble the context.
So for those people who have not been like terminal users, just explain what Grep and sed and awk are in plain English.
Yeah, so it's basically when you use Control F for find in any application and give it a string, and it goes.
Or Command F for dudes like me.
It finds the relevant passage in the body of text that you're looking at. It's the Unix terminal equivalent of that. And there's just different styles, right?
So there's regular expressions and things like that. So it's trying to do matching. And it probably doesn't have a data structure to go and look at. It's not indexed to anything. It's putting everything in memory. And then, I mean, that sets context window in some sense.
And it does requires a little bit of intelligence, right? So because let's say that I have a file about company strategy, right? And let's say that I'm asking a question about what are we going to do about customer acquisition. It's not just going to search for customer acquisition. The model will say, oh, if they're talking about customer acquisition, the words used may be acquisition, the word
merger,
maybe, or like demand gen and things like that. So it will have a few guesses that which words might be relevant to this topic, and then it'll construct a search command with those words.
And then it'll give it to the CPU, which is the terminal running on the laptop. So obviously a lot has happened in the world of terminals. the word terminal is being used a lot. Also thanks to people like Alex who have popularized the idea of terminal bench, which at some point we'll go back to as well, because we have a new benchmark coming on using CPU and GPU for a lot of AI. What else has happened? Like, obviously SpaceX has gone public, right? And XAI is the new AI company, which is probably, it's very clever how they're going to be a data center company. And my conjecture is that it will really make the Neoclouds sweat a lot, especially CoreWeaves of the world, because I think XAI at the very least will be good with atoms, like the way they have to deal with power and land and data center buildings and
vertical integration, right? That's Elon's biggest strength. And I think data center build is all about vertical integration, and
which is going to be fascinating in the coming years. I mean, I've not bought any SpaceX stock, but people say it could be a $30 trillion company. And Elon could be the first quintillion, whatever that means. Looks like we're just in a completely new world of what companies are worth and so on. Sometimes I bite my tongue. I'm like, man, I just hope that once they go public, they also survive the scrutiny of ARR and revenue and all that other stuff as well. Because I was thinking about this yesterday, that the analysts will actually be a different level of scrutiny of what, not just what growth means, but defining what ARR means and things like that as well. Obviously Cursor got acquired a few days ago. They were on the high like 8-9 months ago, and then Claude Code comes. So say a few things about that, between Cursor and Claude Code. Like, what happened that Claude Code took off and people were writing off Cursor?
So I think the fundamental differentiation that Cursor had was good IDE UX, right? As you are in your developer environment, you're typing code, they had come up with the best UX for a developer to get assistance from LLM to do auto-completion, right? Like things like you select a particular section of the code, and then now you're expressing that I don't want any other changes, just in this section. And those kinds of things is what made Cursor very popular.
And this is before context graphs and code had become relevant? Because it looks like what you're saying is that there was a human in the loop with Cursor.
Yeah.
And Claude Code is like, why do you need a human in the loop?
Exactly.
And a visual IDE.
Yeah, exactly. So, not that Cursor couldn't do the same thing, but there's a paradigm shift in how developers interact with code.
But also, they could not have done the same thing because the harness was non-existent. The harness was the human.
Yeah.
Remember the cut and paste, and you're saying this is the... So the agency was still human.
Yeah.
Is that right?
Yeah. So, like, what I'm saying is that, kind of the ground shifted. And so what used to be Cursor's strength is no longer relevant. Now they could build in this new paradigm and come back.
Because Agent SDKs are open source now. Using the harness could be... But look, the reason why OpenAI and Gemini are behind again is because delivering a harness on a laptop with a terminal-like sort of capability and compute and all that stuff is not easy stuff. It's one thing to deliver software in a browser, and it's another one to deliver it on a laptop. Anything to say on that?
No. I hadn't thought a lot about it, but obviously the challenge that comes with it is that substrate is going to be so different, right? Like Windows, Linux, Mac, different Linux distributions and stuff like that. Although I have to say that Python has made that dramatically simpler, right? Like the Python distros take care of most of the underlying things.
I mean, the issue is the sandbox.
Yeah.
How do you really gain trust
Yeah.
of the fact that this harness is only going to use this data, which is this folders and these directories, and as opposed to everything.
Yeah.
And I think we've had to go through thinking hard about the word sandbox. Like, and Mac and Linux, it's been a bit easier without really having to use Docker. But on Windows, you have to think hard about Docker. And then the hard thing is, how do you deliver it for a mobile experience as well, where the harness is actually running in the cloud?
Yeah.
So I feel like there's a lot of cloud engineering, including shipping code to a laptop through firewalls and going through mobile device management and all sorts of MDM software to say, how do you do upgrades? Because you're not allowed to just push code to an individual laptop like that. So there's a ton of work in thinking about how much resources are you using on the laptop, especially in environments where people don't have big Macs and things like that.
You're right. And I think that's the difference between enterprise and like just consumer developer market. Because Cloud Code has a flag called dangerously don't ask permissions. And most of my Cloud sessions are running with that flag.
Man, I was thinking hard about all the other discussions we've had where I'm like, your idea of personal memory and what you want to share with the rest of the world. We'll talk about that, by the way. I'm making a case for memory right now. But obviously a lot has happened in the last 3-4 months. And yet there is so much to come. We live in this really exciting era of learning. I would just call it learning, And I think in many ways it's so paradoxical. It's a great time to build a company. And I think the piece that even my son these days reminds me of the word problem finding versus problem solving. It's become easier to solve problems, at least prototypically. As a prototype, it's become easier to solve problems. But finding problems and finding leads, as in your case, you're actually going through that as well. Like, who do you sell to? And knowing that these are the right problems to solve is probably where a lot of judgment will come in. Anything to say on problem finding?
So here's the thing, right? Everything has become so easy yet so hard. And in that paradox lies all the challenge, right? Like, you talk to anybody and the first brush, their impression would be like, like Cloud Code has made it so easy. I could code this on weekend and I'll be off to the races. And I think there's obviously a lot has changed. The access to coding as a paradigm has been democratized. Like, anybody can essentially give a few instructions and get working code out at the other end. On the other hand, I think building reliable professional software still requires a lot of expertise and judgment. And I think the idea of like grinding it out to build something that's just working code to a product is lost on a lot of people who are kind of thinking that they can shortcut this world. I'll give you a perfect example. It's surprisingly easy to put together an agent before a sales call that goes and does prep work for you, right? You know the company, you know who you're meeting, do a deep research, you get some content, you marry that with some of your own content. You put it in front of somebody who's like, wow, it would have taken me hours to do. You can put together that agent very quickly. Now, imagine if the same agent runs for every meeting and basically the same template shows up in front of you before every meeting. There would be some useful things, like you would pick up one detail or the other, but pretty soon you would be bored of it and you would see very little incremental value in it because there's no strategic thinking involved in it. Like, how do I approach this meeting differently than the other meeting? And bringing that level of thinking, like I have like 5 to 10 engineers working on it for the last couple of months, and still like polish, make it better.
Yeah, I mean, I say that happy path is easy.
Yeah.
It's the paranoid path.
Yeah.
In software. And by the way, it's always been the case. The best developers, the best designers have always had to think hard. And this was the problem with chatbots of the last decade. That they were built for happy paths.
Yeah.
And they just couldn't figure out the negative testing, the boundary conditions, the edge cases. And that's where it just broke. So 80% of the time, the inputs from the end user were incomplete, so these things would just break. And I think it's equally true for code as well.
Yeah.
It's easy to come up with a happy path code, but to find problems in code, and problem finding, which is failure mode finding, is the hardest part. And that's what experience is. Experience is about knowing how things will break. Everything that can break will break, and if you can memorize that and then give it to a coding agent, it's way better software. I mean, that's what I feel it will really create amazingly good companies, is when you think about failure modes more than others. And again, it goes back into the bucket of problem finding.
Yeah.
Like, could you find the problems ahead of everybody else? Because if you've just built happy path software, then the customer is finding problems for you.
Yeah.
And then you're iterating and you're reiterating and you're like, okay, fine, let me patch this. As opposed to when you left shifted a lot of problem finding and you were able to conceive of paranoid sort of code.
Yeah.
That was, I mean, going back to our days of try, catch, finally. I mean, we would look at people who would not have a catch and finally. I'm like, man, how do you do all that? Or folks who never wrote good destructors. Right? I'm like, how do you think about, you created state happy path.
Yeah.
The object was created, but you don't know how to destroy it. Right? I mean, memory leaks. I mean, obviously a big reason for Java's taking off was, hey, people forget to do memory management, so we can do it for them. And that was the problem with happy path developers. So I think there'll be a lot of good things to build when you can have software that is really good at finding problems upfront rather than finding it with the customer where they become your tester or something.
Yeah.
You said something really unique about where the world should be headed. I'd love for you to introduce the problem statement for today's session.
Yeah, so when LLMs came, people's first introduction to it was, for most people, was ChatGPT, right? And that was all the rage. The chatbots were all the rage because there's so much knowledge for the first time was just accessible and you could query it. And then the next thing became, I have all this other knowledge that's not there in the models, but it's sitting in some file or some file system. How do I bring it? And then RAG became the popular thing where you search the right context, inject it into your prompt. And then the next thing was like, okay, LLMs are very good at sort of fuzzy reasoning. They're not very good at precise compute. So let's give them tools. So we were building tools and teaching LLMs how to invoke which tool, when, and then workflows became a thing. And now the agentic coding, where you start from a goal and the system does everything. The next frontier in my mind is going to be memory. Because the biggest thing that the LLMs are missing is the deeper context about the customer, the enterprise that they are serving. And all of this is never kind of documented in one place. You figure this out in the stream of work, and then you need some way to capture it. Now, obviously, at one level, memory is very easy. You just write it to a file, and now it's stored, and you can recall it. But the challenge is that imagine if our brains stored every perception, every moment in its raw form. And every time we needed something from the past, we had to go and reprocess like exactly what happened, every word that somebody said, or like every experience that you had. Like memory is about making meaning from what had happened so that you could use it in future. And more than that, memory is about goals. Like what can I infer from what has happened in a way that it helps me solve future problems. Like for us, it was evolution that was guiding the goals. That's why amygdala plays such a big role in memory.
Fight or flight.
Yeah, so it's trying to take something happen and attach an emotion to it. An emotion is basically saying how strongly it's correlated with my goals. Is it like a survival danger? Is it like something that I felt really, really extraordinarily good about? And that tells us that whether this is a significant memory or not.
And it looks like it was the most basic react loop in some sense, right? You know, reason and act in some sense, right? Fight or flight. There is a lot to be said about memory. I've been thinking hard about and maybe you can also provide some color, but I'm like the KV cache in the transformer loop.
Yeah.
In some sense, is a short-term memory. You know, like okay, I need to think about what the context is when I say it or there or she or he and so on. The word former and latter and things like that. There is a KV cache that is being used for the context window itself.
Yeah.
But obviously, it doesn't scale because I need to look at things that are beyond that context window.
Yeah.
You know, and therefore the version of the KV cache that needs to sit outside the transformer loop is no different than the way we look at DRAM versus CPU's L1, L2, L3 cache, right? I mean, there is L1, L2, L3 cache on Intel CPU or NVIDIA GPU.
Yeah.
And then there is stuff that needs to go over a DRAM to fetch. And then from DRAM we go to disk. And even disk was tiered from flash to or even NVRAM to SSDs to drives and things, hard disk drives and so on. So looks like there's a whole tiering of memory. Are we basically thinking like that from all the way from an L1 cache of a KV cache to the way memory has to be spread out?
So I guess there are two different threads to pull on here. One is a pure compute optimization, right? So KV cache is a perfect example that I could get the same output without KV cache, but it will take a lot more GPU cycles. And like, since I had already done some of this compute, I have it in cache, why do it again? And the entire CPU memory hierarchy is also like that, right? You could get the exact same output without all the caching infra. It will just take forever to do that. You would be going to main memory all the time.
Which is probably 10 to 100 times more expensive than the on-chip cache that exists.
And so KV cache is a great example of that kind of compute optimization. Maybe like the vector DB inverted index is another example where like you could search for that passage by linearly passing through the entire thing, but now it's organized a little bit better so that you can get to it quickly. The other aspect of memory has to do with learning. So it's giving you more than the raw data to be able to make future inferences. For example, like when we learned to ride a bike, initially it was very hard because we were processing the raw sensory input and trying to figure out what's the next action to balance the bike. Over time, we learned to take the raw sensory data and turn that into meaningful signals that like, oh, I'm leaning this way, I'm leaning that way, I have too much forward momentum or something. And then it became easier to ride the bike. So it's about processing what happened in the past and making meaning out of it that helps me with my future goal. And that's the other thread to pull on in terms of memory. So to make it more concrete in context of agents.
Maybe what you're saying is that the signals, the data also needs to be tied to actions.
Yes.
Right?
Yeah.
Like when this happened, there's a small rule to say, then do this next, and so on.
Yeah.
Is that what you're trying to point to?
So in a simplest form, memory exists today as a file, right? And ChatGPT has one, Claude has one for you and I. When, let's say that I'm iterating on an email draft, and I say that like my voice is not this, but not that. My voice is like just explain the thing in its raw form. Don't do any throat clearing. Or if I say like I like my emails to start with a very short warm greeting and then dive into the subject. Now, there's a background thread that's trying to infer my preferences based on that and going and writing it in a file. So the next time when I'm drafting email, I don't have to give these instructions. That already sits in the file. So that's kind of the most raw, most basic form of memory.
But when you talk about future actions,
yeah,
I guess, and I want to take it even a further like step back to the deep neural networks, weights and biases.
Yeah.
Like there is a nano memory in the weight.
Yeah.
Right?
Yeah.
Because going from this layer
Yeah.
to the next layer,
Yeah.
there's probably some nano memory that's saying take it here rather than take it here to the next layer in the neural network. Looks like that is a form of memory too, right? I mean, the weights are a form of nano memory or something.
Yeah,
right?
absolutely. So the challenge with weights as memory is that once you stop training the neural net, it stops learning. And then people have tried like fine-tuning and LoRa and stuff like that to add additional knowledge on top of pre-trained models. It hasn't been a very successful mechanism to use in all kinds. So in certain narrow specific cases, it's useful to do that.
Mm-hmm. And so there's nano memory.
Yeah.
Then there's the KV cache memory.
Yeah.
And then of course there's the macro memory. And we should probably put like two things there. One is the user and their personal memory.
Yeah.
And then there's the enterprise or the shared memory.
Yeah.
Of the entire company.
Yeah.
So take us through that journey of like the weight is a nano memory.
Yeah.
And then the KV cache is a ephemeral memory which can take it back to the context itself, the context window itself. And then from there, how do we get to personal memory? And then how do we get to shared memory? And along the way, when you talk about future, how does what are we associating memory with? You think it is like fight or flight actions that if this happens, fight. If this happens, go away, run away. Is that what you mean by future sort of actions?
Yeah. So let's maybe start there, right? So the point I'm making is that memory architecture of future for agents cannot be horizontal, cannot be general purpose, because what you put in the memory, how it's organized, is going to be very dependent on what's the purpose of this agent. It cannot be devoid of that, because it's not just about memorizing past, it's about organizing the past in a way that it's quickly accessible and usable in future for the goals that you have. So like if you take like general purpose ChatGPT or Claude interface, people use it a lot of times to draft emails and stuff, or like write documents, and so their style, their preferences is what makes sense to go in the memory. When I'm building memory for AmpUp, where the goal is to help the organization sell better, that's the specific goal for that memory. Like what can I learned from the past that is useful in future. And you talk about personal versus enterprise. This is where the silo breaks, where like the best seller has a way of doing things, and now it's in the enterprise memory and accessible to all the sellers, even the bottom quartile sellers. Right? So when I'm building this memory, there's a data structure for every rep that says these are their strengths, these are their weaknesses, these are their key moves at different stages of sales. There's a data structure for every stage of the sales, that when people enter stage 2, these are the ways in which they get stuck, and these are the ways in which they actually get to move to stage 3. There is organization level memory that this is what we've been seeing, these are the competitors we've been seeing, this is the best response to positioning against these competitors. So there's a lot of synthesis involved in processing the past and then organizing that based on what my future goal is. If my goal was customer support, then I would be organizing things around like product features and areas where bugs get organized and different kinds of problems.
In fact, it's very interesting you say that about shared memory, because a ticket resolution is like dedicated to that customer, having that complaint against a provider or their software and things like that, or their process. Now, that is kind of personal between the customer and the provider.
Yeah.
But the moment you anonymize the ticket and make that into a knowledge-based article, now it's a shared memory across all customers, because now AI can actually go use that new KB article.
Yeah.
So we think a lot about like, how do you take this personal lesson of this ticket being resolved, maybe with a human in the loop, and how do you take that and really anonymize it and make that into a KB article that others could use, is also an important piece of this. So there is personal memory, there's shared memory, and you mentioned a few things about how can one seller's skills be used across by others as well. We think of the word team intelligence a lot. Like, what does team intelligence mean? And how do you organize memory within a team? How do you even think of hierarchical teams? How do you put an agent in every team as well? Because these could be very different agencies, depending on where you are in the hierarchy. Especially in the enterprise, these things matter because you're really organizing a lot of things. Even with companies with fewer employees, you will probably have lots of hierarchies of agents as well. And visibility will play a big role. Like, what are you allowed to do and what are you not allowed to do and such as well. I think the term you used was vertical. How do you really make it verticalized? I mean, one end of the spectrum is you use flat files. And you're using, markdown files to really recreate data structures. And the other end of verticalization is I have memory that is built only for oil and gas, or only for retail or transportation or tourism or travel. And there's something in the middle that we have thought a lot about as well, which is, and this is all about B2B AI, enterprise AI. We're like, at the end of the day, there is some notion of subject, verb, object to really think about. It's like really important to think about grammar of memory. And we think a lot about subject-object words. So what does that mean? I think subject is identity. Object is parts. And we'll talk about what parts means. And verb is work. So we have had to really think hard about work, identity, and parts. In enterprise, you're doing work, but whether you're a human agent or an AI agent doesn't matter. You're doing work, and you have to canonicalize work, because at the end of the day, you can't be doing work in a completely ad hoc way, completely non-deterministic way, completely non-explainable, non-auditable way, all the time. In fact, that's where the rub is with React loops doing everything differently every time. So let's talk about work, which is a verb in a sentence, a very important piece. The subject is identity, which is somebody is doing the work, and maybe on behalf of a customer. So you're doing that work on behalf of. So there's two identities. There's internal identities and external identities, and then there is the object. What are you working upon? And that is a product you're building, a service you're delivering. So at the end of the day, you need to look at subject, verb, object. And that to us is ontology. Now to go and layer a level of oil and gas terminology on top of it, or travel or transportation on top of it is the thing on that you need to think about. And that's why the word tickets were like so sort of different in the last 20 years in the enterprise. People said, I filed a ticket. ServiceNow basically said, don't put it as an email because it's not shared with others. You need to take it away from your inbox into a shared inbox, which is basically the list of tickets that a team has to go through, because if you're on vacation, someone else has to act on it. You have to prioritize, triage, assign, deduplicate, classify, cluster. There's all these verbs to be done, and you can't do that when a request is sitting in an email of a personal sort of inbox, and instead do it here. So I think the point I'm trying to make is that the idea of memory, at the end of the day, you could verticalize it going from flat files to just saying, hey, there is a version of it for oil and gas or for healthcare, but there's something in the middle on top of which you can still customize it, where a ticket or a work object could then be customized to actually act like a claim in an insurance sector, because a claim is a body of work. And if you just said, let's start with the word ticket, let's think about states, 10 stages, dependencies and validations and things like that. So there's a lot of state in a piece of work that needs to be structured. I can't see how you could take all that and put it in an Obsidian markdown file or something. So say more on unstructured to semi-structured to structured memory, and what role does that have to play, whether it's personal or whether it's shared memory of the enterprise.
Okay, so there's kind of different dimensions in my mind to cut it, right? So one of the dimensions is, like, if you go into like the study of psychology and how memory is organized, right? So there's this idea of episodic memory, which is raw memory, exactly what happened. Then there's this idea of semantic memory, where we're synthesizing meaning out of raw data, right? So this is where abstract concepts come in. Abstract concepts don't happen in the real world. We're just layering a meaning so that we could make sense of it and we could use that, right? Then there's the idea of procedural memory, like this is how we do X, Y, and Z.
Which are like skills.
And then there's another layer of memory that we've been working on, which is personalization memory, which is where like your entity graph comes into play, and for each entity there is a body of memory around it that's very specific to it. So that's one dimension in which you can cut memory and say these are different types of memory. The other dimension, of course, is the ontology, that like what are the different entities, subjects and objects in the sentence that it relates to. So it could be about a sales rep, it could be about a specific product, it could be about a specific product area, customer, it could be about a region, it could be about a specific stage of the sales cycle.
But given all that you just said, if you try to recreate all of this in an unstructured way, using markdown files, Like, are we regressing to the 1970s and 80s when it comes to databases, or what? Like,
so the tension between structured and unstructured is always going to be there, right? The great advantage of structured data is that you can get to the piece of information that you need very, very quickly, because there's a hierarchy, you can traverse the hierarchy, you can get to it. B, there's like already some meaning associated with each piece of data that you don't have to recreate every time. And C, it's also easy to refresh this, because like, you know what's at a macro level, what's getting irrelevant, what needs to be updated and what needs to be retired and what needs to be added. So there's all of that advantage.
Plus, I think, there is some understanding of illegal states that we also have to remember, that that's an illegal state. And it's really important to also understand illegal access, like what are you not allowed to see, especially in shared memory when you look at the enterprise. So you need to actually have those policies. And unless you have a little bit of a structure, it's hard to assign illegal states or illegal access.
Structure, that's the right word. Like, you're basically putting some constraints on how the memory is going to be, and in most cases constraints are a good thing. There are cases where constraints can hurt you, because like now you're in a slightly different domain, or the world has evolved a little bit, and now you need to, that's when you pay the price of structure, because now you have to change the structure or live with structure that's less relevant. But I think
looks like there'll be both. We probably have to think hard about what does it mean to do structured, semi-structured, unstructured. But the point that I was trying to make is that there's going to be this thinking about structure that ends up using CPUs as much as it's using GPUs. Maybe sometimes even more. And I think the way we have had to think about precision, like you'll see a benchmark come out very soon on Terminal Bench, where we're actually, making a case that the enterprise doesn't have complex tasks. It's complex data. Because every department sprung up its own databases and SaaS systems and things like that. And now the joins are the real culprit, how do you join all this stuff? So in the past, it used to be a data warehouse, destination, and there were data architects and enterprise data warehouse architects who were trying to assign meaning and integrate all this stuff in a Snowflake or a Exadata or a Redshift or Databricks or whatever, But the problem is that they were not good at unstructured data. The problem is they were not good at interactive queries and tens of thousands of parallel sessions. And the problem is that they didn't have any other compute other than SQL, right? So the idea of integration was very important, because it's the joins that kills you. And you can't join in a context window in the mental math that the LLM is doing. Because for one, you're trying to recreate everything the SQL compiler already knows for the last 40, 50 years. So we have had to think about what does it mean, and you've seen this world or tried to see this world for 15 years now with ThoughtSpot as well. Where the natural language to SQL is now an LLM's job, a GPU's job. And you were trying to do the CPU back in the day as well when there were no GPUs. But we think that that's the horses for courses sort of argument. Like, give them the stuff, give them the schema. Because right now they're wasting a lot of time in MCP. Trying to understand schema for every damn user query. Like every session says, now let me understand Salesforce's schema. Now let me understand ServiceNow schema. That also is memory. There's a semantic understanding of the enterprise that needs to be kept somewhere. That not every user query and session is trying to recreate by probing Salesforce one more time. Anything to say on that?
Yeah, so this is where I think the semantic layer on top of data becomes important, right? You, instead of giving SQL as the tool use primitive, you're giving a higher level semantics as the tool use, where you're translating the query into higher level semantics, and like everything that needs to be done from there on is already figured out.
Is some code generation.
Yes, some code generation.
But that semantic layer is not just how these things are connected or should be joined, but also this idea of illegal states and illegal access, or permissible states and permissible actions. In the shared memory world is really, really important. But even for a personal memory, like we are gonna put things about what is permissible in an email that's being sent out from an agent's point of view, or what are the things that the agent is permitted to share with somebody on the outside world or not. Really important, right?
Yeah, I mean, even like when you go to regulated industries, right? Like based on regulation, what are you supposed to say and not say to a customer becomes really important.
Yeah, and I think I can't say enough about the CPU versus GPU thing. I mean, my analogy is, electric vehicles. We said everything's going to be batteries. And the reason why it worked for a while, for 5-7 years, is because there was so much of government subsidies on them. So we're like, oh yeah, it's actually comparable, and you get some subsidies. But once subsidies were gone, is when people realized that this is not sustainable. Right now we have subsidies, VC subsidies, and hyperscaler subsidies and tokens. People are like, I can just do everything on the GPU, and why do I need to do anything smarter? And then when reality struck, people said, oh, it's going to be hybrid. There's going to be enough fuel injection and enough battery stuff, and we need to actually have cars that are hybrid. And that's way more sustainable. In fact, I very fondly think of the token maxing anxiety that we have as no different than the range anxiety that we actually have with the battery cars and such. And the fact that the network of supercharging stations and the lack thereof is the same problem we have in the world of tokens too. Like, at the end of the day, you just don't know how long you will last the tokens that you have, and all of a sudden people are at the end of the day twiddling their thumbs and saying, well, Claude just said I ran out of tokens and things like that. So how do you really bring the CPU and the GPU together, where a lot of the memory could be retrieved from the CPU, from graph databases and vector databases and SQL engines? I think it's really, really important. I don't know if you want to say a few things about that.
Yeah, so I'll go to the human aspect first. So I think we can make fun of the idea of token maxing, but the intent behind token maxing was to push people's imagination. Like, there are a lot of people who were sitting on the fences saying that, your cloud code can do something, but I'm the real developer, and it makes so many mistakes that it's not even worth trying and breaking the pattern in which I've been building code. And that's what got a lot of execs to say, like, no, I'm going to reward people who are going to the extreme of maxing out. And that pushed a lot of people in the right direction to expand their horizon and their imagination of what's possible with these agents. But obviously, it's like everything, the pendulum swung too far. And now it's about, okay, now people get that this thing is new and I need to change my workflows, but what is the optimal workflow where I can have the maximum impact without breaking the bank?
And by the way, that to us has been about better prompts, better planning around prompts, being more prescriptive about beyond the happy path. Like, what does it mean? Because I think the problem right now is there's too much wasteful stuff going on. Where people are being lazy
Yeah.
about the prompt. So what it generates, and then you go through unit tests and they fail, and then you can say, hey, well, there's all these other things that could fail. So I think it's the discovery of failure modes. That is wasting a lot of tokens. It's the left shifting a lot of that really will bring some level of sanity to the world of tokens as well. I think the other piece that I think a lot about, we all think a lot about at DevRev is safety and collaboration around memory. That one of the issues with agents will be that they'll act like operators, autonomous operators, and they will make mistakes, just like humans made mistakes in the 90s when data was coming from paper to a paperless office where things were in databases. And as we digitized a lot of the data, we made a ton of mistakes. Database administrators had a lot of oops moments along the way. They dropped tables, they were partitioning the wrong thing, and they were creating the wrong indexes. There's a ton of reasons why we had backup and restore and point-in-time recovery, and obviously disk drives failed, and failure modes happened for various reasons. So machines were failing and people were failing with their operations. So we needed a lot of safety around data. So I know that Anthropic talks a lot about safety of AI itself, and which is all through guardrails. We need similar sort of rollback thinking and point-in-time recovery thinking and versioning thinking and paranoid thinking around version everything, reversion to the previous state. It's a really important piece of the puzzle, because if you unleash all these autonomous agents, without you having this memory, there is no verb in Salesforce to revert things. Right? There's no verb in any of the Google Docs or what have you to really say we can revert things as well. And it is a very important piece of memory is can you at least unlearn stuff as well? Can you forget things? Can you forgive the operator? Anything to say on that?
So it was a couple of months ago that there was a blog where essentially an agent went and deleted the entire database of someone's operations. So these things have happened for real. And I think it's not that happened and everyone changed their mind. Like people are like, fine, there is some risk associated with it. I'm gonna take the risk for now and take the upside. But like as we get more and more into this, we'll have to figure out the right safety mechanisms.
And by the way, this happened. I mean, I go back to MySQL as an open source, like really taking off about 20 years ago, maybe 18, 19 years ago. And there was fast engines like MyISAM, which didn't have transactions, didn't have backups. And then there was InnoDB, which was the thing that had backups. And then there was Postgres that had no online backups and things like that. And you could see in a matter of 3, 4, 5 years, it was pretty evident that MyISAM is dead because it didn't have protection and safety. There were no transactions. There was no rollback. Forget about backups. There was no rollback of a transaction. If you're running it for 3 minutes and 2 sessions clobbered over each other, it was like basically dead. It was fast, but it was not safe. And there's a reason why InnoDB succeeded. In fact, there's a reason why this combination and MySQL did way better than Postgres. For 10 years, Postgres was in a hibernation because they didn't have hot backups. People had to shut down the database, make a copy of these files, and even upgrades were actually not online. So there was a lot of things around being online, being able to upgrade, being able to back up things while the thing is online. That really made the difference between what MySQL was and what Postgres was. I feel like in the world of enterprise, memory needs to be safer. And AI, the only way to make agents safer is by making sure that the actions they're making are
Reversible.
Really, really important.
Yeah.
And then finally, collaboration. I think the piece, how do you use memory to collaborate?
Yeah.
I mean, right now there's a lot of memory in Slack.
Yeah.
Right? And Teams.
Yeah.
But I think what I miss is there's no AI in Slack. Like you go in a channel, you have team members, and there's a lot of memory about the channel, about the topic that you're discussing.
Yeah.
First of all, it's syntactic channels.
Yeah.
It's not topic based, it's not semantic. And secondly, I don't have an agent that I can refer to and say, hey, what do others do in the rest of the world?
Yeah.
If a design discussion is going on.
Yeah.
So there is a best practice that AI can actually bring that resolves conflict in a channel as well. I don't know if you feel like memory will actually bring in a level of team intelligence and collaboration with AI that is completely missing in Slack and Teams right now.
That's a big bet. That I think it's almost like human contribution is going to be on the derivative of like intelligence, not on intelligence itself. That like my value in future I see is like, how do I contribute new and novel ideas to this team intelligence, as opposed to just continuously executing on the fixed set of patterns that have worked for me for the last 5 years.
So you're talking about evolution of memory, like where people are adding to the memory, but also it's evolving. It's a very interesting thing you said.
So the idea was that, let's say I'm really good at taking requirements and converting that into code. In past world, I could just continue to thrive by new requirements keep coming in. I convert that into code, and I'm a strong developer. I'm valuable to the organization. Now, as soon as it's been done enough that expertise can be encoded into a model or an agent, that thing is commoditized. So the only unique thing that I bring to the table is like, what's a new and better way of doing it based on my lived experiences and my mistakes and my insights.
Could that be versioning of skills?
Yeah.
Because just like versioning of state
Yeah.
is what we've done in the past 34 years.
Yeah.
Are you talking about versioning of skills?
Yeah. So I think if my job is to make skills better and better and better, there's obviously going to be newer versions. And in some ways, you could say that it's no different. Like we were doing better and better versions of code, but now we're talking about better and better versions of how you create code. And so that kind of gets into the derivative.
Maybe we should actually come back to this in the next episode, because I think versioning of agents to discover agents, versioning of skills to discover skills, especially as we think about MCP and such. And I mean, it looks like there's a new consortium that got created just last week where Google and OpenAI and Meta and others are trying to come up with an agent discovery sort of protocol or some such thing, which is kind of Google's new thinking about A2A and things like that. But it probably gets into skills too.
Yeah.
Because as you're saying, the more I think about it's like beyond state, it's skills themselves that need to be versioned. We've done this with API gateways on APIs were the skills, and we had Envoy proxies and things like that to discover APIs. But there's probably a lot more here about how do you version skills and how do you, take care of redundant skills, because there could be a lot of clutter when it comes to overlapping skills and all in the enterprise as well, right? So maybe that's an episode in itself. We should talk about skills. So maybe you've gone through a lot with memory. How do you want to summarize it for the audience? What should they take away? And then maybe we do an episode on skills alone, which could be actually quite, a learning experience for us too.
Yeah. So I at the high level, what I want to say is that memory is the next big thing that not a lot of people are thinking about and aware of, but like how agents get better is going to be memory. And memory is kind of the other side of the learning loop, right? Memory is how agents will learn. And the most basic form, of course, of memory is files. And like people sometimes are putting comments in their code and that becomes the memory. But given how important it's going to be, memory will get a lot bigger and a lot more complex very soon. And then you need some sort of structure on top of it. And how you organize memory and what you choose to put in your semantic and procedural memory is a function of your future goals. And it cannot be devoid of it. So what that means is that depending on what your goals are, depending on what kind of jobs your agents do, the structure of the memory is going to be very different, which is why I think how memory is organized for like a sales technology, customer support technology is going to be different. And people who are experts in the space and who are going to dedicate a lot of time and energy in thinking and organizing would have better agents than kind of flat horizontal agents. And in some ways, memory to me is like a reinforcement learning problem. You will get a reward in future for remembering the right thing and surfacing it at the right thing, and you will probably learn along the way that what is the right thing to prioritize, putting in memory and putting some structure around it based on the kind of problems you face in future. So there's probably going to be a lot of fundamental research, engineering, and then product thinking around memory that's just getting started.
Beautiful. Yeah, while you were talking, I was just thinking about the 640 kilobytes of RAM that people have attributed to Bill Gates.
Yeah.
I mean, that 640 kilobytes of RAM to me is like the KB cache. That's all you need is a KB cache. And that's all the world would need no more than 640 kilobytes of RAM is basically that. And obviously, the more state we actually put around computers, the more we realized how much we need to think hard about not just, volatile RAM, but also non-volatile RAM and storage and databases and all those things. It's like the organization that took place after that. The file systems, the databases, the L1, L2, L3, L4 caches on Intel, and then the DRAM, the DDR technologies, and even the, just the system bus bandwidth and all that stuff, because we had to really fetch so much context to really do computations. I think is no different. So we basically in the mid 80s right now, where we probably have started to scratch the surface of the KB cache being the 640 kilobyte of RAM. But how do we really think about the trillions of tokens, which is the real context of the enterprise? I love how our CTO Ahmed Bashir talks about this. Like, how do you go from trillions of tokens to 1 million tokens that you need to feed, or even less, to the LLM? Is about really this you got to really go through this exercise of reduction. It's very reductive exercise on an every inference basis, and that's where memory will be very, very useful. And it needs to be organized. You need to think about permissible states. You need to think about permissible actions and access. And I still have the skills piece unresolved. So I think I understand state well, but going back to skills and how you talked about skills, we can get some clarity while rumbling with each other in a subsequent episode. And how you structure skills, whether it's through MCP or this new thing that some of the companies are talking about, and how do you take care of the clutter? I mean, it was in the hands of developers to go and do memory management before Java said, we'll do it for you, because we know what reference counting means and all that stuff. I think we'll have to think hard about a lot of those things, because there'll be a ton of clutter around memory as well. Skills that are overlapping and people are using similar things and yet they're different. To me, we're going to create a mess around skills that at least I feel very uncomfortable about as well. But hopefully we'll get some good resolutions as we go and talk about this in the future.
So here's a question maybe worth ending at. So far, every technology we've created, it starts simple, and then you start layering more and more requirements, and it gets complex. And then humans have to go and figure out what's the right organization, what's the maintenance structure of this, how does this thing evolve, how does this thing get maintained. And that's been true for every generation of technology. Is it going to be any different this time, that like maybe humans don't have to do it, maybe the models can manage it?
Yeah, I mean, there's obviously, we are an agent,
Yeah.
and we'll have to provide some feedback. Because at the end of the day, what are we talking about? It's just modeling. In some sense, we are helping the model actually understand atoms and bits, things that the model still doesn't fully understand.
Yeah.
I mean, we don't have robots. We're not in an autonomous world. We still have a lot of humans acting as agents, whether they're drivers or forklift operators or conveyor belt operators. There's a ton of atoms that we are also managing, and then of course there's a ton of bits, like the fact that we had a conversation with a customer, and we need to actually go provide the right sort of model inputs. That's the reason why we exist, and that's the reason why we'll continue to have a job. So I think there's inputs to be had from a very important signal processor, which is our brain. And I think we'll continue to provide those inputs to make sure that at least the chores and the repeatable stuff. I sincerely believe that if we can let the machines take care of the chores and the repeatable stuff and the boring stuff, the next generation will work on more interesting problems. That's just the way it should be. And I mean, it happened with even trading, like on Wall Street, there used to be a ton of people just carrying these checks in their hands and saying who's the right buyer and who's the right seller. And of course, digitization happened, and these days with high frequency trading and algorithmic trading, most of the bankers and people who have been really doing trading now is a more complex trading. It's not the chores. Buying and selling stocks. They're creating new vehicles, new derivative structures, dot pools and all sorts of things that is in the domain of the human now. It's not like Wall Street has shrunk. It's just started working on bigger molecules than the smaller ones that I think algorithmic trading can take care of or something, So that's kind of the world that I am hopeful about. And hopefully with memory, we can make it that much more explainable,
Very cool. Until next time.
Thank you, everyone.